Thank you, Daniel, for the introduction. I hope it is, but it's not sticking there where it should. So, all right. So, like Daniel said, I started with the open source IMS core actually back in 2004, very long ago. Well, it was open source in 2006. That was before Kamailio a little bit, so we didn't know better, so to say. But it is on the C++ router, so the common root. And yeah, unfortunately, I kind of, wanted to finish my PhD some years ago, and I stopped working on IMS. The research was dying down as the technology became more mature and so on. And yeah, last year I already talked here about the OpenEPC project a bit. So this is a continuation of that, going more towards a product and what we have been doing lately. Well, we hope to close on OpenIMS that we're going to bring it back. I think the guys at Kamailio did a great job, actually, making sure that those modules and all the work that we did not be. So you can find it all in there. It's in Kamailio IMS. Recently I just discussed again with Ron. We hope to bring back the name OpenIMS to as products and so on.
It's a dangerous stuff.
Yeah. He's doing it on purpose. So we hope that we're going to bring back OpenIMS, especially as we start with OpenEPC deployments. And a lot of people, they just tell us, hey, we know that you guys also started with OpenIMS, so why not a bundle between the two? All right, so today I just want to talk a little bit about distributed mobile networks. Well, basically, it's a little bit what this community did for telephony, but we're trying to do the same thing for mobile networks. Namely, before SARE and before SIP and so on, telephony was mostly a big vendor and a big operator game, right? And you couldn't just play with this thing and try it out. But now we're saying you don't need a data on a mobile network. Yeah. We put it on a Raspberry Pi also, so we didn't bring it here because, yeah, in the meantime, a lot of people did that. It's not a big philosophy anymore. It's just software, hardware evolved, software evolved. So this is definitely possible. The next step that we're trying to do is somehow opposite to SDN, network function virtualization, and so on. We're saying, well, maybe it will be cool to have distributed mobile networks. Yeah? Why does it have to be centralized? Why do you need a data center? And especially, we always had this problem. When you're trying to say, I want an email server, you never think about racks, cooling, power, and so on. You go online, click a few buttons, you get an email server. Big philosophy, right? Tomorrow, you need to scale to 1 million email accounts. Buttons. So why isn't it like that for a telephony network? Well, not for a telephony, sorry, for a mobile network. Why do you big racks and so on, and why do you go like that about it? Sure, you have MVNOs, but what's the next step to distribute? So in these slides, Alberto helped me like to start with a sort of contrasting background. You have there an old guy in a suit, an architect, trying to design something. But we want to do things differently. We want to make it decentralized. Why? For agility, first of all. Yeah? What does that mean? We want to be able to scale into just where without having to worry too much about this central big hardware hardware components and software components, but just, hey, you need this capacity here, you need more coverage, just go and you put another box in that place and you cover that also. We also want autonomy, so This really is about deploying that network and having it fully enclosed at that point, not saying, oh yeah, now you need an uplink so we can connect you with this big data center there and do the whole authentication and so on. This is why we came up with the SIM cards, because that we're giving some SIM cards for free. We can tell you how to provision them there. Not really for any operators, you don't have free data and so on, but more so something in the sense of, here's a SIM card that you can have, and then we can show you how to have your own mobile network. So I had this experience with, that I'm talking about this and people are thinking, yeah, okay, this guy has some components and they did this software and so on, but mobile network, it's a big thing. It's a very complex thing, and he cannot just do it like that. But the moment that I said, hey, here's my SIM card that I can just provision on my network, people start, oh, wait a minute. So can we do this? Can we get this to work? And yes, we can at this point. And the other point is resiliency. And if you look at the internet, it's all very distributed. I don't care if some parts of the network fail. In my network, if I have backups and stuff like that, everything is going to be fine. So decentralized networks, we think it makes sense, especially for some very special cases like public safety or military and so on. So use cases.
Sorry to interrupt.
Yeah.
The audio is jittering.
Yeah, sorry. It's.
I can fix it.
Yes, please do.
If you want to.
Please do. Oh my God.
I love you.
All right. Thank you. All right. So what use cases? I said, well, public safety is one use case. Yeah. What do you think these guys are using? They are using actually Tetra or Tetrapol, which are parallel technologies to what we are, doing in the telecom world. And it's very interesting for the governments and the state and so on, because they poured immense amounts of money into these technologies. And today, if you compare that, performance-wise, it's sort of like edge. So, you have this experience that every time that you see a policeman on the street, just ask him, why is he using his iPhone and not his device? Yeah? It's a completely different experience and we think that this is the next big step for them. They're going to switch to standard technology, to using LTE for the efficiency, for the fact that they can source and they can make a phone that is going to be way more cost-effective than what they have right now, with much better performance and so on. Next use case, what you want a decentralized network, are all these remote, rural, and all these cases where you start from saying, well, even building a tower and so on might be too expensive. And then you have to consider how do you link that location to your main location. Over satellite, latency might be super nasty. Are you going to install an cable just for that location? So for those situations, we want to make it possible that you run on that island the whole mobile network without even having to worry, oh, where do I put the back? What if I don't have power on this island? What happens in that case? So really for these cases where you are off the grid, offshore and so on, so you can't rely on regular infrastructure. Or we've seen also lately that we rely extremely on our mobile phones. So in case of a disaster, and what do? You try to pick up your phone and then you realize the network is down. It's going to take a long time to take it back. We heard, that operator said, well, I had 1.5 meters of water in my data center, so yeah, this is going to take very long. After they fixed that, they said, oh, but the undersea cable was also cut, so yeah, it takes months. I mean, you've seen the recent earthquakes and so on. And these are big infrastructural problems that you have, and you're not going to solve on the spot. So you need something small that really is really not relying on anything that you have there or you might not have anymore. And yeah, humanitarian operations or construction sites, it's also a good, an interesting use case. Yeah, we don't want to scare you guys, but of course, military, it's also a use case in here. But yeah. requirements, I already mentioned some of them, so you can guess them. Self-contained. You don't say, things like, oh, I need a roaming agreement or something like that, or I need to connect to another network. I have to do interoperability tests with them before starting this network. No, it has to be fully self-contained. In the outside demo, you'll see that we even have a smart card reader. So for us, you put a SIM card in, we provision your new identity, you put it in the phone, basically in seconds you are online. And everything is, self-contained in that system. You have really everything that you need. Of course, management, you have to deal with it in a proper way. Some of the use cases that we have, they say, look, I just want 2 buttons from you. One says off, one says on, and that's it. No matter how badly this box breaks, they're going to use it on site. Don't tell them about CPURIs and transactions and whatever. No matter what, that's the button that should make the box come back to service, and that's the resilience. Sometimes also you don't have an established infrastructure, so you need a mesh network in the backhaul there. You just say, well, I have connectivity from here to there. How? Maybe Wi-Fi, something. We figure something out. And these boxes should just sort of auto-discover themselves and work together to create to create a mobile network as best as possible. Services, you need data and voice. So when we talk, for example, with public safety and so on, we ask them, what do you need actually? Do you need call? Push to talk, it's very clear. They want to push, hey, help me. Come get me out of here. But what do they need? And they come all the time and they say, well, I need data, I need SMS, and I need calls. So you need the regular subscription kind of, from a regular operator. Yeah, but I need it also when those fail. So the services, it seems that they already, embrace the mobile domain, and they already have started developing apps and so on, and then you rely on these services, data, voice, and even SMS, and that's what they want. And then technology-wise, well, LTE is very efficient, is the cool thing. Wi-Fi, it's something that you could use every time that you might have headaches with spectrum licenses and so on. But also 2G and 3G is still important. When you go to a tester area and so on, you shouldn't expect to say, oh, if you want to be saved, you better have an LTE phone, or otherwise I'm not going to find you. Yeah? Now, the network there for disaster relief has to run also 2G and 3G in parallel and be sometimes a sort of no authentication honeypot. Yeah? Because the network that existed there is no longer there, so you should just say, well, hey, welcome to my network. Where are you? Need anything. Dial 1 for water, dial 2 for food. Yeah? Dial 3 if you have a really big emergency and you need us to pick you up. But it has to work on existing sort of devices, not on something that we would wish that populations in remote areas would have. So this is what we have. We've seen it in our stand. We try to package it also in some people would understand that this can be made small, can be made effective. So this is a no cooling, no moving parts system that, well, still consumes a lot of power, about 60 watts and so on, but this is a cheap box. We can also put it on an ARM and get even decent performance, even on some very small Raspberry Pis. But everything can really put in a single small box like this that, sometimes we're thinking about it. Where do you put this box? And we say, well, on a tree. There you put the cell, there you put this box, and that's it. Power-wise, that's why we try to use the power consumption and everything. So, when you put it in a tree, the next thing is, do you think I have a power socket in the tree? I need solar or something. You have to figure out. So that's why we try to reduce a lot the power consumption in these things. Unfortunately, we can try to do something on our side, but on the radio side, if you say 10, 15 kilometers, well, you're going to need a lot of power for that radio, for that base station. So that's unfortunately something that we cannot get out of it. You want to go farther away, you're going to use more power, but at least for the core network, we're trying to do the absolute minimum that somebody could do. So the technology, well, it's based on what I've learned, so to say, at Focus. So if you know how to write a module in Kamailio, we said that it's going to take you probably half an hour to make that module compile on our platform. So the platforms are really similar, but of course we didn't have SIP. We did not need SIP for what we are doing. We did a lot of other protocols. You see our big ones, GTP and so on, Diameter, big workhorses, but to do all the 2G, 3G, LTE and so on integration, those standards were not made so that we could have fun implementing them. Quite the opposite. So it was really, really hard to get all of those things, and I need a different slide to list all of them. But slowly and surely and so on, this is, we made a big investment into it, and we managed to implement, almost all of them. We even do these days some base stations ourselves, so we are trying to really, cover with this platform everything that we can. We have, I think, 165 modules on our platform. Everything is, of course, all IP. So we still have some legacy things and so on, but these also work over IP, like map and so on. These are for the cases that you say, well, I want to deploy this, but I still want to rely a little bit on my existing infrastructure because I don't want to reissue 10 million SIM cards or something like that. Okay, we have a solution also for that. We can interface. Or if you say, oh, your SMS center is cool, it's based on, it's working on top of Kamailio IMS, and basically it's a Kamailio process that, just exchanging some sort of instant messages with some strange bodies in there. But I have to interface with these other operators. I have to send them SMSs and so on. So how do I deal with that? We built also those protocols so you can deal with legacy. And of course, how do you do telephony? Last year I talked about this MSC, this mobile switching center, that we managed to actually make 3G circuit switch voice work without requiring a big SS7 whatever infrastructure and soft switch and so on, but directly we translate it to SIP and RTP, so that for telephony you can use an IMS, or, well, don't be scared too much about IMS. You could also use a standard SIP core, register, session border controller, load balancer, so I don't say SESEF, ICSEF, proxy CSEF, but basically it's the same thing. So we managed to make it in such a way that if you come with your phone and you register, you attach to 2G or 3G, a SIP register goes out. You want to send an SMS to that guy, you send a SIP message. You want to call him, invite, and that's it. So way, you have a single ICS there, IMS centralized services. You have a single telephony core, both for circuit switch 2G and 3G telephony, and for LTE and Wi-Fi packet switched based telephony, so to say. These are all the protocols that we implemented so far. And we're still adding some to this list. It has been a crazy journey. We think that we implemented about 100, we used about 100 man-years to get to this state. And some things that probably you're never gonna be, in the distant future, like BSSAP for 2G and so on, but also some very new ones like OpenFlow. So we have also thought about what do we do in, in an SDN environment. Can we handle 100 gigabit per second easily? Well, we said yes. An OpenFlow switch that can put through that many packets, not a problem. We can simply send some rules to it. Then we can outsource from standard x86 architecture that cannot really take this today to that OpenFlow, hopefully hardware sort of implementation. So where is Kamailio in all of this? You can probably guess, that we have, so to say, our base connectivity platform, and on top of that, we're using, of course, the Kamailio base. It's what we worked before, this open source IMS core, the modules. Well, they always had a common platform, so with SIP Express router and so on. So obviously these days we are using them on Kamailio to provide the voice services. And a bit of about challenges, but not too much. I'll just try to speed a little bit through these things. The number one challenge is how to make this network, work where you have a bunch of cells, and for every few cells you're deploying some of the boxes to the mobile. But each of them does the full functionality. So if you get disconnected with this side, let's say, this can still work on its own, can provide telephony inside. Where you try to call outside or something like that, you can get phones and things like that, but still inside should work. So challenges were how do you do these handovers between these connectivity islands, because it's like jumping from one network to another roaming network, but you want to keep your IP address, you want to keep your call going, and so on. And basically, 3GPP only thought about the situation where you're going to do a handover between some cells that are connected to the same core network, but we want to go really beyond that and optimize that. You can do this change between these networks, and well, hopefully, if they're connected, your calls are going to still be going. Almost nothing happened. Because we have this decentralized architecture, we have also these advantages. The whole architecture was taught for centralized, deployment of components. So we have some increased signaling for tracking area updates and so on. But our current customers for special, they're not really that influenced by this, because is still fast enough to handle this overhead created. And additionally, when you're moving between these networks and you're doing this sort of bigger handovers, and you're even moving, so to say, IPs around, in the sense that changing routes and everything, you want to do that fast. When you move from cell to cell, you basically have no packet loss, and we want to do it the same way. So the big challenge was how do you minimize that, interval that you are still trying to attach to the new network? How do you eliminate the fact that you might need to re-authenticate to the new network and so on, but just make it look like a regular cell-to-cell handover. So in that case, we're moving a lot of state between these nodes, and we are trying to keep them synchronized with each other. So then, when they see a new phone, they're not going to be, oh, who are you? Let's start authentication. Let's see, what phone do you have? Identity, let's challenge you, and so on. But it will be a more straightforward, oh, you've been there last time. And if you use the same cipher key, we're going to be, really fast in contact, and we can continue really fast communication. The second challenge is the mobility. So in the sense of finding the subscribers where they are, and this is also for Kamailio and IMS, because you're moving from register to register, but you want to do that very fast, and you don't want necessarily to send another registration and so on. So you have to find the user really fast. You cannot afford broadcast every time you have a call or something like that. So for that, we are trying to synchronize, for example, the HSSs in the background with each other, and trying to do some smart broadcasts, so minimize the amount of traffic on the backhaul, which also could be quite unreliable. Plus, this additional thing, typically in the standards, you can do a handover while changing some parts of the components that you're connected to with the serving gateway, but there is no standard for how to do that with the PDN gateway. And we're also trying to do that, so that comes from Forum for Focus. Of course, we've done a lot of R&D in there, so these things are not that difficult for us. It doesn't matter that there is no standard for this. We can come up with something and make it work. Unfortunately, it doesn't always work, so are definitely a challenge. So very large scale mobility is really an issue. It's something that we also say that, well, this is also a problem on the current internet, because you cannot just say, I'm going to go mobile on the whole world and keep IP while I move from country to country. It's the internet today is still routed geographically in very large parts. So we have the same problem, but it all depends on the scale and what do you want to do and how many compromises are you willing to make. So if you're not China Mobile, you don't have such. And it's also, how do you want to compromise in the sense of, is it okay if we change your IP address from time to time to optimize a little bit the traffic, then things are better. And of course, talking about network function virtualization, all the trend that you have in the industry, it's very cool because you have everything in data center. So if you want to do an update, it's very easy. You just update that. For us, for a distributed network, things are harder. We deploy these nodes in places that you cannot really reach back to them. So we have to come up with even new ideas on, okay, what do we send to these guys on these islands so that we can reach back to this node and to make an update. So the updates are more difficult in the end. So as a bit of an outlook, outside we have this demonstration already for special use cases, public safety, ruggedized solutions. That's something that it's very easy to approach at the beginning because, how many subscribers do these guys have? Well, 1,000, 10,000 total. Okay, we can forget about many of the challenges before. The next thing that comes up are these enterprise or vertical networks. So if, I don't want to say that Asterisk is outdated or something like that, but some years ago, it was all the rage about just forgetting about your old PBX and replacing it with Asterisk. It still is today. But what we've seen is that also companies are starting to think, well, yeah, that was cool. That happened for the fixed telephony. Can we do that for mobile? What's the deal? The new technologies should support LTE and Wi-Fi. I have Wi-Fi. Can you give me a femtocell? I can install a femtocell in my company, and then can I run my own network? Yes, you can. It's what we're trying to do next, trying to approach these kind of customers, that love Asterisk, and they say, well, okay, can I do that with my LTE phone? Yes, you can do that, and you can still use Asterisk to handle your calls. And Kamailio, of course. Then the next market is a little bit more difficult for us as a small company. These are the mainstream commercial networks. We still get, even today, requests from that direction. Yeah, the market is really different in that case. We, as a company, our value is in customization, not necessarily having oh yeah, I want to deploy this network. It has to cost less than a cent per subscriber. Okay, that's something that it's very interesting. At this point, software. So what we can do best are all these customizations and going for these special cases where rather than coming saying, I want everything. I'm the big operator. I want every service, everything that is in the book. Rather, our customers, they would come to us and say, well, I want this, I want that, and interoperability would be cool to have, but it's not the most important thing. So, well, I forgot to switch the slide. But basically, that's the main idea for enterprise networks. The thing that I think we think that's really upcoming, so that you will have small cells indoors, just like you deploy Wi-Fi. The base stations for LTE are really not much bigger than that. They're just, you can have base stations that are just as big. Outside of your company, you will be roaming. Then you can have customization. You can trust that the local traffic stays local. It doesn't go through some big routing and data center facility somewhere away that you don't really know what happens in there. And of course, it's standard Linux software, so you can apply and so on principles very easy on that. All right. Thank you very much for your attention. I would end up with something that I found this morning by mistake. Deploy wireless, should be easy because, what did he say? It's wireless. How hard could it be to not install wires?
Right.
Thank you.
Thank you, Dragos. Questions about what's happening here? One question for me, because as you know, I'm with Kamailio, but looking also at this part, are there interfaces like to control from, like, let's call it VoIP platform back to lower layer?
Yeah. So I think we contributed those. So they were part of OpenIMS Core, but you can also use them in Kamailio IMS. It's the same thing. So we contributed those. Basically, you have, I would say, two at least big ones. First, the RX. You can request QoS from the LTE network. You can, basically tell what you want to do, and we can improve the quality if we can on LTE. But also very important, and something that a lot of people don't know that this is possible, is that we are going to notify you back in Kamailio, and we're going to tell you, oh, now you are on Wi-Fi, so you can try to do some extra things. You can increase the bit rates or decrease the bit rates. I don't know if that's better than what you had on LTE and so on. So you get all these events back. You can get a lot of things. You can get whenever we lost connectivity to the phone, or if you have a system where you ran out of data and you don't have money anymore on that mobile subscription. But that interface is there. That's one of them. And the other one that we also contributed, and it's in Kamailio also, it's a shared module, actually, exactly the same thing on EPC. It's the offline charging. So you can integrate the charging that you're getting from, saying, hey, okay, this call used 5 megabytes of data transfers and I don't know how many packets. You can correlate that with how many minutes it took in SIP and so on.
Great. Other questions here? You have, can you pick? There.
Yeah, good morning. Good morning, everybody. Hey. A dangerous question. You know what? I think all the stuff that you're doing, Dragos, is absolutely brilliant. But
the open source thing.
No, it's not the open source thing. It's,
I would love to.
In order to be successful, there's a whole load of additional stuff that you've got to do. And Simon will agree with me, I think. The technical stuff is probably the easier part of it. The difficult bit is doing all the commercial stuff and all the GSMA stuff that you've got to go through. So in order to make these things work, you've got to have IR21s, AA14s, AA19s, and you've got to be a full member of the GSMA. And in order, because if you turn up and say, I've got this big lump of open source stuff, I want to connect it to your network, they just turn around.
Not even open source,
not even open. Of course, it's not open source.
Sorry. We would love to do that. So just to close on I understood your question. So we would love to go open source, and as much as we can, for example, all these modules, for example, Diameter, the CTP module that you see in Kamailio, that's basically something that we started with OpenIMS Core, but then we improved, and we will continue to improve it a lot more. We're going to add SCTP pretty soon to it, and so on. We have it already in OpenEPC, and we're just testing it, and so on. So we're trying to contribute as much as possible back. but it's a different thing. It's something that we need a big team to develop, and
yeah, I'm sorry.
I don't know about the model.
I said open source, and
no,
I'm a bit dozy.
That's right, because we also are misleading the name open.
Yeah, it's not open at all. Well,
Yeah,
you
but
get
you know how
access
to-
to the source code if you want to.
Yes, you can get access to the source code, and also it's a bit of a branding. The name of the institute is Fraunhofer Open Communication Systems, so it's open everything, open MTC, open 5G, open anything that we've been doing there and so on.
To cut it here, yeah, we name it SIP Express Router and we make it open source, and we name everything else open. And
yeah, that was, this worked. So let's call everything open. But then back on I think you're going towards certifications and all of these things, right?
Yeah, what I'm thinking is we got to do a little bit more work, making things a little bit easier for the smaller people to swim in the pond.
Yeah, we see this a lot. So we see this a lot every time, you talk in this sense, and they say, yeah, but you have to interface with this network because, number one thing, we're doing prepaid, and how do you do that? Oh, there's a old map interface, and it's legacy, and you're lucky if it's over IP. You're right about that. Technically, we have all the interfaces. You're hitting some walls there in the sense that, really that they tell you, big operators, they just tell you, we don't interface with you if you don't buy this specific hardware from this vendor, and this is the point of interconnection to you. We don't care what you do behind that, but that's the point. But on the other side, I can just turn the question around to Daniel and say, did I stop you from making Kamailio? Because it was the same thing there, right? ISDN, all of stuff. Come on.
Yeah, you're absolutely right. We mustn't stop, but
exactly. So
but we've got lots of big problems to deal with. And a lot of them are commercial, political type ones.
I guess
but here's the
Dragos can take it offline on this one.
He's kicking me
because I know you can discuss. James sits in mobile. Dragos sits in mobile. There are arguments left and right. So. If it's a last question...
So we're going to build a ring in the corner and put them into the ring and see who survives. Any more questions?
Okay. Thank you, Dragos. Thank you again. And again, supporting the event.